Today we're doing section 2.2 day 1 and we're graphing quadratic functions. So just a quick little recall from last year, vertex form of a quadratic looks like this. F of x equals a times the quantity of x minus h, the quantity squared, plus k. So to determine if it opens up or down, if our a value is positive, it's opening up. If a is negative, it's opening down. The vertex would be HK. So I always say, notice to the students that it's opposite of the inside value, same as the outside value. To find our x-intercepts, you set the equation equal to 0 and solve for x. To find the y-intercept, you plug in 0. So we're going to go through one example like this. So based on our information, we know our a value is -2, therefore the parabola is going to be opening down. Because we're in vertex form, it's very easy to identify the vertex. The vertex is going to be 3, 8. And now this is where we're going to have to do some work. So let's find our x-intercepts first. We'll set this equal to 0 to solve. As far as solving, rather than foiling it out, I'm going to keep it like this. I'm going to subtract the 8 over. And then we're going to divide both sides by this -2. So now I have 4 equals the quantity of x minus 3 squared. To solve for our next step, we're going to take the square root to get rid of that squared. So the square root of 4 is a plus or minus 2 equals x minus 3. So remember, because this is squared, I'm supposed to get 2 answers. So don't forget, when you square root, you need a plus or minus. Then we're going to add 3. So I'm adding 3 to 2 different values. I'm adding 3 to a positive 2, so one answer is 5. Then I'm adding 3 to a -2, so the other answer is 1. So that is our x-intercepts. And lastly, we've got to find our y-intercept, and we do that by plugging in 0. So we're finding f of 0. So we'll have -2 times 0 minus 3, the quantity squared, plus 8. So 0 minus 3 is -3. -3 squared is a positive 9. We multiply, we get -18 plus 8. So our y-intercept is equal to -10. And now that I have all the information, the whole purpose of finding this is to go ahead and create the graph without using a graphing calculator to do so. So our vertex is at 3, 8. 1, 2, 3, 4, 5, 6, 7, 8. Then we have x-intercepts at 1 and 5. 1, 2, 3, 4, 5. And then our y-intercepts at -10. Bear with me while I count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we can reflect that point because we know the axis of symmetry goes through the x part of the vertex. So that's all the information I need, and it's plenty of information to go ahead and create the picture of our parabola. So let's go ahead and try one more. So our a value is implied to be a 1, so I know the parabola is opening up, and I know the vertex is at a -3, 1. To find the x-intercepts, we're going to set this equal to 0. And we're going to start by subtracting this 1 over, so now it'll be equal to a -1. And to get rid of the squared, we're going to take the square root of both sides. And one thing that we discussed in the beginning of chapter 2 is that the square root of a negative gives you I, and because there's a square root, it's going to be plus or minus. And then the last thing I need to do is subtract 3. Now the problem is I can't actually subtract 3 from an imaginary number, so my x-intercepts are -3 plus or minus I. And what this means is my parabola is not actually crossing the x-axis because the x-intercepts are imaginary. Now we find the y-intercept, so I plug in 0. So I'm going to have 0 plus 3, the quantity squared, plus 1. So this will give me 9 plus 1, so our y-intercept is equal to 10. So now we're going to get this information on our picture. So I'll plot the point -3, 1. So 1, 2, 3, 1. So here's our vertex. Our y-intercept, again, bear with me. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Barely made it. And because this is the axis of symmetry, I can reflect that point. So I need to go over 3 more spots because the x distance is 3. So the point will be at 6, 10. And now we can create our picture. So notice, again, it's not crossing the x-axis, and that's why we got the imaginary x-intercepts. All right, that's all for today.